Okay, hello everyone. Today I'm going to talk about base preconfirmation with Mr. MEV-Boost. I'm Lin Oshitani from Nethermind Research. Okay, so most rollups, let's talk about most rollups today. So most rollups today build their blocks using centralized sequencer. So users send their transaction to centralized sequencers, the L2 transactions. The centralized sequencer will sequence the L2 transactions, eventually construct these L2 blocks, submit it to the L1 block building pipeline, and then the L1 block will include these L2 blocks. And centralized sequencers are nice. They can provide preconfirmations. And preconfirmations, what are preconfirmations? Basically, users, for example, submits their transaction C to the centralized sequencer. The centralized sequencer will return a preconf, which will say, I will promise to include your transaction C at the third position of the L2 block after transaction A and transaction B. And then some time passes, and then the centralized sequencer will actually submit this L2 block. But the thing here is this preconf will happen way ahead of time, before the L2 block is actually submitted to the L1. So it provides good UX. So centralized sequencers are nice. They can provide fast UX via preconfs, but however, they're centralized. So the big question here is how do we decentralize? So one idea here is what if we remove this sequencer role entirely? And this brings us to based rollups. So based rollups, the idea is to use the L1 block building pipeline to sequence not only the L1 transactions, but also the L2 transactions. So the user submits their transactions, not only L1, but also the L2, and then the L1 block building pipeline will sequence not only the L1, but also the L2 blocks. So let's expand this L1 block building pipeline part. So this is like what the L1 block building pipeline looks like right now. The user will submit their transaction, and then there are going to be builders who are going to collect these L1 transactions, and then they're going to construct blocks. And then there are going to be many builders, and then there are going to be many blocks, and then each are going to submit a bid to the proposer. The proposer is going to select the most profitable block and then propose it. So the idea of based rollups is that let's use this same pipeline that was used for the L1, which is used in blue here, also for the L2 transactions, which is using the red arrow here. And base rollups are great. They inherit the L1 censorship resistance and liveness, because there is no external entity other than and we only have the L1 actors that we already have right now. And it also enables L1 composability, because these L1 builders, they will have full sequencing rights over the L1 and the L2. So they can act basically as a shared sequencer between the L1 and the L2, providing composability guarantees. But there's a problem, which is base rollups are slow, because there is no preconfirmations here. So to address this problem, there's base preconfirmations. So base preconfirmations, the idea is this. Let's let the L1 proposer opt in to provide preconfirmation during their slot. So the user can directly send their L2 transactions to the L1 proposer. The L1 proposer can directly respond with a preconfirmation. And then later on, the L1 block building pipeline runs, and then the proposer will ensure that these L2 blocks are included in the L1 blocks that they propose. So one observation here is that providing preconfirmation requires sophistication. Because the proposer here, you have to have some API or some RPC endpoint to provide the preconfirmations, and you also need to run the L2 full nodes to actually sequence these L2 blocks. So they would probably want to delegate, and they will want to delegate to what we call gateways. So the idea of gateways is this. The proposer can delegate their preconf duties to gateways ahead of their slot. So the proposer can say, hey, this is my gateway. Please send your preconf request not to me, but to this gateway. And the gateway will be responsible for responding with preconfirmations. And then eventually the gateway will sequence the L2 blocks, submit it to the proposer. Proposer will include it in their L1 blocks. So gateways are nice, but they have some problems, which is, first, the inheritance of L1 censorship resistance and liveness is degraded. Because now you have this gateway entity that didn't exist in the L1 block building pipeline that is now sequencing the L2 transactions. And now L1 composability is also made more complicated, because you no longer have an entity that's sequencing both the L1 and the L2. Because the gateway is sequencing the L2, the builder is sequencing the L1. So the question here is, can we introduce base preconfirmation while retaining the good properties of base rollups? And here comes our proposal, which is called MR-MEV-Boost. So it's acronym for multi-round MEV-Boost. And the idea is this. So let's split the slots into multiple subslots, aka rounds. And in each round, let's run a MEV-Boost auction to pre-confirm a partial block. So this whole L1 block learn pipeline that's sequencing both L1 and L2, let's just run this whole thing many times during the slot. So instead of running it once in the 12-second duration, run it every 3 seconds, for example. And this pipeline is nice because there is no additional entity added to the pipeline. So there is no gateway here. And as a result, we inherit the L1 censorship resistance and liveness much better because there is no additional choke point to the system, and also enables L1 composability because the L1 builder now is like sequencing both L1 and the L2, or they're like pre-confirming both L1 and the L2 at the same time. Okay, that it is. Thank you very much.
Yeah, thank you.